Okay, so what I'm going to do is I'm now going to plot these points up on the screen here. I am going to go and start with y equals 1 minus x. So,
Are we saying that you can't reach the y-axis?
yeah, well, actually, it can't reach two of them, yeah.
Isn't last lesson we did x?
Exactly right, yeah. So, you might remember from last lesson we were dealing with a horizontal asymptote. And here we've got a similar instance, but we have vertical asymptotes. So we'll start negative 4 is at negative, so it is negative 0.25. Negative 3 is at negative 0.33. And then negative 2 is at negative 0.5. Negative 1.5 is at negative 0.67. Negative 1 should be at negative 1. Negative 0.5 is at negative 2. Negative 0.25 should be at 4. And then negative 0.10 would be at negative 10, so it's about here. So we get a very lovely looking curve like this. Okay, there's one part, and then we keep going at 0.10, that's at 10. 0.25. Of course, I'm being a very naughty maths teacher and doing a sketch, doing a graph in pen. I'll make sure to tell myself off for it for later. 2. 1. 1.5. 0.67. This is 2, 0.5, 0. Remember, these last few points are going to be very approximate. And then you should get a very lovely looking curve. You'll notice that, like the last ones, the exponential, there's a horizontal asymptote. Where is the horizontal asymptote? At y equals 0. Yeah, there's one right here. Yes, there is 2. And then the other one, which is the vertical one, as indicated by Mr. Musgrove earlier. And the way we write this, because obviously the horizontal one I wrote as ASYM y equals 0. The vertical one I write ASYM x equals 0. Because it's along when x equals 0. That's the vertical line there. And again, it's still dashed. And you'll notice the line is going, instead of trying to get closer and closer to 0, but it can't, what it's trying to do is it's getting closer and closer to infinity. So it's getting, that's where the asymptote is forming. And that is purely because, obviously, the closer it gets to 0, the larger those numbers we're getting. ASM y equals 2. So, how could you possibly relate the equation to where those asymptotes are? Has anyone got a way that you could describe where you could predict asymptotes of hyperbolas would be just by looking at the graph? Mr. Daniels, what are your thoughts?
If you've got a +2, it means the horizontal asymptote moves up by 2.
Yeah. This little +2 at the end controls the horizontal one. So if that said -5, the horizontal would be at y equals -5. Yes.
Does that mean the -3 moves the...
Yeah. Much like everything else. Yeah, that x minus 3, minus being like the brackets, being like the exponential, like everything else, it's moving to the right by 3. So this under here controls the vertical asymptote. Moving it left or right. I've got a graph of 2 over x. And this was my graph of 1 over x. So basically what this does, this 2 at the front, is a dilation by a factor of 2. So just a reminder, this is a dilation by a factor of 2 from the x-axis. That dilation actually makes it wider. So it actually will look something like this. So that's y equals 2 over x. Just to compare,
So what happens if you had a huge dilation, like if you had 10 over x or something like that? Would it basically just be full?
yeah, well, you'd have to zoom out the screen, but yeah. But yeah, that's the difference between the two. The reason I know that, I just took a shortcut and we just were multiplying our plots by 2, and we noticed that they get bigger, or they're getting bigger the closer it is to 0. But you can also show that on your CAS calculator as well. So yeah, that was the original graph, y equals 1 over x. When I've got 2 over x, it actually just makes them wider. So here's a question. So now this graph hasn't been dilated. In fact, the rest of them haven't. They've just the same shape as the original. What's happened to this graph on here? Where would the vertical asymptote be? Yes.
To the left.
It has moved 2 to the left. Spot on. And where would the horizontal be? Yes, Miss Mullins.
1.
No, because it hasn't been moved up or down. So it's just moved left. So it'd be...
Yeah, let's see.
That's all right. So it would still be at y equals 0. Now, of course, we've got a y-intercept there, so we better plot that. Could anyone tell me what would be the coordinate of the y-intercept? So when x is equal to 0. What? So I'm just replacing the x with a 0. 1 over 0 plus 2. Yeah, so it'll be just a half, or 0.5. So, in the test, which is tech-free, I basically just want to make sure that you can sketch a graph relatively accurately in terms of moving it left or right or up or down. That is all I'm worried about. What would be the y-intercept here? Oh, Mr. Spaulding. 0.2, you say? So 3.2, yep. Yeah, so that's a comma, by the way. So yeah, so Mr. Spaulding rather cleverly converted 1/5 into a decimal, being 0.2, and then added 3. So it's 3.2.
Are we putting the X-Intercept as well?
Yes, we are. So this one's a little bit trickier. We'll need to do some working out for this one.
Y equals 0 minus 3.
So yeah, minus 3 on both sides. So this is to find the x-intercept, by the way. Okay. There's a couple of ways you could go about doing this. You can do the tricky way or the proper way. I'm going to multiply both sides by the denominator. This is the long way, but I know people get confused about my upside down fraction thing. Okay. Divide both sides by -3. Don't need to expand it all.
Do you have to make it an improper fraction?
Nah.
No? Okay.
I mean, it's always better to make it an improper fraction, but...
Oh, that's so annoying.
No, well, your mixed numbers in the long term in Year 12 would be much more annoying than an improper fraction. So that becomes -5.330. Would anyone be game enough to tell me where the vertical axis or vertical asymptote has moved in this one on the bottom right?
2 units to the right.
It has moved 2 units to the right. Yes, it has. And would anyone else like to tell me where the horizontal asymptote has moved? Mr. Tan.
The one bottom. The bottom one.
Yeah, so yeah, we want to know where's the horizontal asymptote moved? Sorry?
Down.
You're down by how much?
5.
Yep, it's to be moved down by 5.
Bottom.
Okay. So again, we'll need to find. Would anyone like to tell me what the Y-intercept would be?
Negative.
Oh, hi. It would be -1/2 minus 5. So you
Come back.
that's right. -5.5.
Yeah, that thing.
Okay. And we'll need to calculate. That's a 5.5, by the way. We'll need to calculate the X-intercept when y equals 0. So 0 is equal to 1 over x minus 2 minus 5. Add 5 to both sides. Multiply both sides.
So if you had a negative x, would it just swap to the other two?
That's correct, yeah. So if it was reflected, it would be the other way around. Spot on. I will leave that up for anyone who needs it.